I'm Anil Kumar, and in this video we will learn how to solve linear systems by elimination method. Determine the coordinates of the point of intersection for the linear system 3x plus 5y equals to 7 and 2x plus 4y equals to 6. As you can see from here, isolating any variable x or y leads to fractions, and so that is going to complicate the solution. So in such cases, we adopt elimination method for finding the point of intersection or solving a linear system. So let's begin by copying the given system, which is 3x plus 5y equals to 7 and 2x plus 4y equals to 6. Now to eliminate any variable, we need to make their coefficients exactly same. So let us say we multiply the first equation by 2 and the second equation by 3. When I say multiply the first equation by 2, that means everything in it, all the terms, right? Similarly, all the terms in the second equation will multiply by 3. Then 2 times 3 will be 6, 3 times 2 will be 6. These two coefficients will be same. Once we take away one from the other, we can eliminate the terms with x. That is how the elimination method works. So let's multiply by 2. What we get here will be 6x plus 10y equals to 14, and second equation will become 6x plus 8y equals to 18. 3 times 4 is 12y. So we are multiplying by 3. 3 times 2 is 6, 3 times 4 is 12, and then this is 18. So we get these equations. So these are our equivalent equations. We can number them as equation 1 and 2 for the time being. In fact, let's say this is 1 and 2, and these equations are 3 and 4. 3 and 4. Okay. Now, to eliminate, we should take away one of the equations from the other. So let us do equation 4 minus equation 3. So if I take away the top equation from the bottom equation, reason being these numbers are higher, so we'll get positive values. That's the whole idea. So what are we going to get? So what we get here, 12 minus 6x minus 6x is 0. 12y minus 10y will be 2y. So we get 2y equals to 18 minus 14, which is 4. And now we can divide by 2. So we get y equals to 2. So we get a value of y, which is 2. Now to find x, let's say this is equation 5 for us. To find x, what we can do is, we can use one of the original equations, substitute the value of y as 2 and calculate x, right? So this time, let us use equation 1 and substitute y equals to 2 from equation 5, which is y equals to 2 in equation 1. In that case, we get 3x plus 5 times 2 equals to 7, which is 3x plus 10 equals to 7. 3x equals to 7 minus 10, which is minus 3, and x is equals to minus 3 over 3, which is minus 1. So we get x coordinate point as minus 1 and the y coordinate point as 2. Therefore, we can now write down our answer, and the answer is minus 1 and 2. Now it's always a good idea when you get your answer, check if it really works. So if I write minus 1 for x and 2 for y on the left side, do I get 6? This is what we should be checking for, right? So let us check. In the second equation, if I write minus 1 for x and 2 for y, what do we get? We get minus 2 plus 8, and that is indeed 6, which is the right side, correct? So it works. So it works. So that check works. Since we calculated this from the first equation, we know it will work in the first equation also, right? So you understand in this particular example, when the coefficients are such that isolating variable leads to fractions, we should adopt the method of elimination. And that is how it works. And it's a good idea always to check your answer with the given equation. Thank you.